Welcome viewers. In this video, we'll see the solved problem based on the losses and efficiency of the DC generator, the part 4. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. Find the efficiency at full load and half load for a 1200 kilowatt 600 voltage sun generator using the following data. Armature resistance RA is 0.005 ohm, sun field resistance RSH 60 ohm, brush drop equal to 1 voltage per brush, mechanical and iron loss at the rated load is 20 kilowatt. So these are all the data available. We need to find the efficiency at full load as well as half load. Now we'll analyze the given data. The output power is given 1200 kilowatt. Kilowatt means 1200 into 10 to the power 3 watt. The kilo means we need to multiply with 10 to the power 3. And armature resistance 0.005 ohm. Sun field resistance RSH 60 ohm. The terminal voltage is 600 voltage. Brush drop equal to 1 voltage per brush, so that the total brush drop equal to 2 voltage. There are 2 brushes available, so 2 into 1, 2 voltage. Mechanical and iron loss. So this it is known as a stray loss. Mechanical and iron loss together is also called as a stray loss, that is 20 kilowatt. It means 20 into 10 to the power 3 watts. So these are all the data available. From that we need to find the efficiency. First we will find the output power. Output power P equal to V into IL. This output power is given and the voltage, terminal voltage also given. So from that we can find the load current IL. IL equal to P divided by V. The P is given 1200 kilowatt. So 1200 into 10 to the power 3 divided by terminal voltage is 600. So that 2000 ampere. So the load current is 2000 ampere, that is calculated from given output power and terminal voltage. Then sun field current ISH, that is equal to, because of sun generator, ISH can be written as V divided by RSH, because the sun field is connected across the armature, across the load. So the same voltage is applied across the sun field. So ISH equal to V divided by RSH. The V is 600 voltage divided by RSH is 60, that is equal to 10 ampere. For the sun generator, the armature current is equal to load current plus sun field current. The sun field current, this IL plus ISH, because the armature and load and sun field all are connected in parallel. So in this armature, the current coming from the armature is diverted into load current as well as sun field current. So sum of these two is the armature current. So these two values already we calculated, 2000 ampere and 10 ampere. So 2000 plus 10, 2010, 2010 ampere. Armature current is 10 ampere. So from this armature current we can calculate the copper losses. Copper losses one by one. So the armature copper loss equal to IA square into RA. This IA is calculated 2010. So 2010 square into RA is 0.005. So that is equal to 20,200 watts. Then sun field copper loss ISH square into RSH. The ISH is 10 ampere. So 10 square into 60, that is equal to 6000 watts. So the sun field copper loss is 6000 watts. Then brush loss equal to VB into IA. VB is the voltage drop at the brush, that is 2 voltage. So 1 voltage per brush, per 2 brushes mean 2 voltage. The IA value is 2010 ampere. So that is equal to 4020 watts. Right. Then this is mechanical plus iron loss. Stray loss is already given in the problem, that is 20 kilowatts. So 20 into 10 to the power 3 watts. Right. So now we calculated armature copper loss, sun field copper loss, brush loss and stray loss, that is mechanical and iron loss. Now we will go to the total loss. So total loss equal to armature copper loss plus sun field copper loss, brush loss plus iron and mechanical and iron loss. We need to add all the values, right? These values are we already calculated. So by adding all this we got 50,220 20 watts. Right? The total loss in the generator is 50,220 watts. Right? Now we calculated the total losses. So we note that input equal to output plus losses. So the losses we calculated, output also already given. So by adding the output and loss, we can able to find the input to the generator. So right. So the output is 1200 kilowatt, 1200 into 10 to the power 3 plus losses is 50,220. That is equal to 1,25,220 watts. Right. So this 12 lakhs 50,220 watts. So it's not, it is 12 lakhs 50,220 watts. Right. So when the input is given, that is converted into output and some losses will be there. So that by adding output and losses, we are able to find the input. Now we have the input as well as output is available. From that we can easily find the efficiency. These are all for the full load value. So the output is 12,200 kilowatt divided by 12,050 12 lakhs 50,220 into 100, that is equal to 90.9 percentage. So for this full load value, the efficiency is 90.9 percentage. Now we'll go to the half load. So half load, first we need to find the half load power. Half load output. What is the half load output? That is nothing but total output divided by 2, because half load only we are applying. So divided by 2. So that is 600 into 10 to the power 3 watts. That is 600 kilowatt. Right. So the power output at the half load is nothing but total power divided by 2. So correspondingly, the total load current of the half power, load current is IL equal to P divided by V, because the power is reduced, automatically the load current also will reduce. Right. So IL equal to P divided by V. So 600 into 10 to the power 3 divided by the voltage is 600, that is nothing but 1000 ampere. The load voltage is 1000 ampere. Earlier it is 2000 ampere. Now reduced to 1000 ampere. Then armature current IA equal to IL plus ISH. This ISH is constant. It is 10 ampere. Right. So the IL is now 1000 ampere. So 1010 ampere. Right. Earlier it is 2010 ampere, 2020 ampere. Now it is reduced to the 2010 ampere, now reduced to 1010 ampere, this armature current. So due to half load, the power is reduced, load current also reduces and armature current also reduces. So with this armature current, we can find the copper loss. We can repeat the process, same process again. Armature copper loss, IA square into RA. So 1010 square into 0.005, that is 5100 watts. Sun field copper loss, ISH square into RSH. So that is equal to 10 square into 60, that is 6000 watts. So this is independent of the load. So the same 6000 watts will be calculated for full load also. Then the brush loss, that is VB into IA. So this is variable. IA value is now reduced. So 2 into 1010, this 2020 watts. Then mechanical and iron loss is already given, 20 kilowatt. So this is almost a constant, it will not vary with the load. So 20,000 watts. Now we can add all this so that we can calculate the total loss. Armature copper loss, sun field copper loss, brush loss and mechanical and iron loss. By adding we got 33,120 watts. Right. Now the total loss is calculated. The output power already is available. So from the output power and loss, by adding the output power and loss, we can able to find the input, because input is converted into output and some losses. So by adding output and losses, we will be able to get the input. Right. So 600 into 10 to the power 3 plus 33,120. Right. So we got this 6,33,120 watts. Is nearly half, because of half load the input also reduced. Now we are having the output power as well as input power. From that we can easily calculate the efficiency of the generator at the half load. So efficiency equal to output divided by input, 600 into 10 to the power 3 output divided by input is 63 lakhs 6,33,120 into 100, that is 94.76 percentage, right? So this is the efficiency at the half load. So in this problem we calculated the efficiency for a full load as well as half load. During half load mean the power reduces automatically, load current, armature current call, all are reduced. It is nearly equal to the half of the value. Based on that, again this armature copper loss, other losses are calculated. Then we calculated the efficiency. Subscribe the channel for more videos and notification. The soft copy of this material available at the drive. The link is given in the description box. Thank you for listening.